Good afternoon, class. We are looking at Module 5 for Pre-Calculus. Practice test number 5, covering chapters 10 and 11. Chapter 10, Analytic Geometry. Chapter 11, Sequences and Series. Again, reminding you of the pledge, when you take an exam, you take an exam on your own. You cannot receive or give any unauthorized assistance. We've gone over that a number of times. This is extremely important. And so here's chapter 10, Analytic Geometry. All right. Find an equation of a circle with its center at 1, comma, -2 and radius 2. Graph the circle. So first, reminding everybody, what is a circle? Here's the definition. A circle is the set of points in a plane that are the same distance, called the radius, from a fixed point called the center. So here's a circle centered at 0, 0. And following Pythagorean theorem, it gives rise to x squared plus y squared equals r squared. This is the x, this is the y, this is the r. If it's centered at h, comma, k, then we have x minus h quantity squared plus y minus k quantity squared equals r squared. And of course, as you know, the area is pi r squared. The circumference is 2 pi r. So that is something we know. All right, so what do we have here? We have the radius 2, we have the center at 1 minus 2. And therefore, if we want to come up with the equation, we just follow this one. X minus h, that means x minus 1 quantity squared. Y minus -2, that means y plus 2 quantity squared. Because the radius is 2, then it becomes 2 squared equals 4. So with this being the radius, this being the center, here's the equation of a circle. X minus 1 quantity squared plus y plus 2 quantity squared equals 4. And so the center is located at 1, 1, -2. So 1 to the right, 2 down. So somewhere here. And now you go 2 units to the right, 2 units to the left, 2 units up, 2 units down. In other words, r units, r units. So r equals 2 units left and right. So if you go back to the center, or this one, you want to go to the left, that means from the x coordinate, you're going to subtract 2. So 1 minus 2 becomes -1, and then you add 2 becomes 3. The same y coordinate remains. Those are the pairs. Going back to the center, r units up, r units down. So here -2, 2 units up becomes 0, 2 units down becomes -4. So now put them together, and that's the graph. It's very straightforward, everybody. Write the equation of a circle in standard form. Identify the center and the radius. Graph the circle. X squared plus y squared minus 4x plus 10y minus 7 equals 0. So we put x squared and minus 4x together, y squared and plus 10y together, and we move the -7 to the right. We make it +7. And now we do completing the square, everybody, which means in this case, b is -4. You divide it by 2, you get -2. And if you square that, you get +4, which means you need to add +4 to both sides. Over here, b is 10, half of it over 2 is 5, and if you square it, You need to add 25 to both sides. So this is x minus 2 quantity squared. This is y plus 5 quantity squared. 7 plus 4 plus 25 is 36. So the center is obviously positive to negative 5, and the radius square root of 36 or 6. So we locate the center, 2 to the right, 5 down, 2 to the right, 5 down. And then from there, you go 2 units to the right and left. So to the right and left of this point, 6 units, my apologies, R is 6. So 2 plus 6 becomes 8, 2 minus 6 becomes negative 4. And going back to the center, up and down by R units, or meaning 6 units. So if you go up, becomes 1. If you go down, becomes minus 11. Put them together, that's the graph. Graph the ellipse by finding its center and vertices. X squared over 25 plus y squared over 16 equals 1. So let's discuss an ellipse. So here's a shape of an ellipse, and here's a definition. An ellipse is a set of points in a plane, the sum of whose distances from two fixed points is a constant. The two fixed points are called the foci. Each is a focus. Here's focus 1, focus 2 of the ellipse. F1 and F2 represent the two foci of an ellipse. So PF1 plus PF2 equals 2A. What are we talking about? I want to make sure we understand this. If you pick any point on an ellipse connected to the two foci, focus 1, focus 2, the sum will be fixed. The PF1 plus PF2 is fixed. That happened to be 2A. By the way, this is elongated along the x-axis, which means A, this distance is A, is larger than this distance, which is B, and therefore the vertices are at A0, negative A0. These are called co-vertices, okay? And why is this equal to 2A? If that point, you can pick any point you want. If here, then this distance plus this distance is 2A. Or fixed. So as far as getting to 2A, you can pick this point, let's say, let's call this if you pick this point A, then the distance from A F1 plus A F2 is fixed. Okay, and class AF1 plus AF2. Now notice AF2, this much is AF2, is the same as this much by symmetry. So if you replace that, and let's call this B, then you can replace AF2 by BF1, and that becomes AB, and that is equal to 2A. That's the proof, believe it or not. Okay. And so that's as far as why we have 2A. Also, there's another formula I want to mention. So this distance is A, and this distance is B, and this distance is C. This is by Pythagorean theorem. So I want to discuss that one before anything else. B squared plus C squared equals A squared. Let me erase my work. This distance is a focal distance. This distance is B. This distance is A. And it is equal to this red one. By Pythagorean theorem, B squared plus C squared equals A squared. Why is this equal to A? Because if you pick the point to be here, these two must add up to 2A. Each one must be A. So I hope you see all the proofs there. Now, x squared over a squared plus y squared over b squared equals 1. This is when the center is at 0, 0. If it's at h and k, x minus h over quantity squared over a squared plus y minus k squared over b squared equals 1. Now, b squared plus c squared equals a squared. And area, remember the area for a circle is pi r squared. For this one is pi equals pi times AB. The reasoning is very simple. A circle is a special case of an ellipse where A is equal to B equals to R. If A and B are identical, it becomes a circle. And we don't call it A and B anymore. We call it R, the radius. That's why all of these work in the same manner that is mentioned here. And so, centered at 0, 0, according to this is centered at 0, 0. A is square root of 25 or 5. B is square root of 16 or 4. So here's the center 0, 0. And then because it's A is 5, we go 5 units to the right, 5 units to the left. Those are the vertices. Because B is 4, from the center go 4 units up and down. Those are called co-vertices. And now put them together, and that's an ellipse. Identify the coordinates of the center, the vertices, co-vertices, and foci. Graph the ellipse. Okay. Obviously, it's in this format. And the center is located at -5, +7, according to this format. A is square root of 4 or 2, B is square root of 9 or 3. So those are obvious, right? So we can put in the center 5 to the left, 7 up. 5 to the left, this is -4, this is -6, so in between. And this is 6 and 8 in between, so it's the center. Now, A is 2, B is 3. Means 2 to the right, 2 to the left, 3 up, 3 down. So the reason I'm going to go with B units first, because those are the vertices. So if you go B units up and down, okay, so 7 plus 3 is 10, minus 3 is 4, so we have those two pairs. Going back to the center, A units left and right, and A is 2. So to the left becomes -7, to the right becomes -3. And those are the points and connect them. So that's the center, the vertices, the co-vertices, and graph. What is left is the foci. We're going to find the foci. And because it's elongated this way, parallel to the y-axis or along the y-axis, then the vertices are somewhere here also. I want you to know that. So how do we find the vertices? Now, remember, b squared plus c squared equals a squared because a is larger than b. But when b is larger than a, you interchange it. So either a squared plus c squared equals b squared or b squared plus c squared equals a squared. It depends on which one is larger. And in this case, because b is larger, we're going to go with a squared plus c squared equals b squared. And so 4, 9, subtract from it, we get 5, and c becomes square root of 5, which means going back to the center, up and down by square root of 5. Okay. At 2 1/4, roughly. So minus 5 and then 7 minus square root of 5. This is exact. This is an approximation for the sake of location. Minus 5 and 7 plus square root of 5, 9/24. So this is 8, this is 9, 9/24 is roughly here. And 477 is roughly here. So those are the two pairs. This is a rough estimate. It's not exact, of course. Use the graph of the ellipse to determine the equation of standard form. Now, clearly the center is not at 0, 0, so we have to use this formula. We're going to find h and k, a and b. Okay, so to find h and k, let's plug in this one. Clearly the coordinates are -2, +2. So right away, it's x minus negative. That means x plus 2 squared, y minus 2 squared. We have to find a and b also. And to find a and b, let's locate a couple of points here. So we have those points and we have these points. So vertices are located at -2, 5, -2, -1. So this is the distance which is A. This is the distance which is B. Those are the co-vertices. So this distance gives us A. So we're going to go from 2 to 5. Okay, that's B. That means 5 minus 2, B is 3. And we're going to go from -4 to -2. The distance is 2. So A is a 2. A is 2. B is 3, everybody. And so A squared, B squared, there you have it, and we're done. Give the equation of asymptotes and graph the hyperbolas. A, x squared over 16 minus y squared over 25 equals 1. B, y squared over 25 minus x squared over 16 equals 1. So what is a hyperbola? This is the shape, this is the equation, this is the asymptotes. Let's look at the definition first. A hyperbola is the set of points in a plane, the difference of whose distances from two fixed points called foci is a constant. So if you can pick a point, any point, for example, P, and connect it to foci, F1 as well as F2. PF1 minus PF2 equals a constant. That constant happened to be 2a. And by the way, sometimes they use an absolute value because if you have doubts which one is larger, right? Okay, because you could say PF2 minus PF1. Still, it's absolute value of 2a if you go with the distance, okay? Because if you go with PF2 minus PF1 becomes minus 2a. So that's why they put it in an absolute value to be on the same side. In any event, so If that is the case, for example, if you choose this point class, the reason it becomes 2a, if you choose this point, the distance from here to here minus this distance, I hope you see because these two are identical becomes this, which is 2a. So in other words, that's a proof and you can look at the lecture. Okay. Now, the way I look at it, x squared over a squared minus y squared over b squared equals 1. Remember, it's the same as in essence ellipse. This becomes negative. And y squared over b squared minus x squared over a squared. If you keep the b squared under y squared in all times, then the equation of asymptote, regardless of this type or this type, will be plus minus b over a times x. Okay, and that's why I do it this way. In some texts, they change the location, and it changes this equation. So I highly recommend you do that. Now, the same as ellipse, the relationship between A, B, and C follows Pythagorean theorem, but this time C, look at the distance. This is the distance C to F2 or F1 from the center to F2. This is C. This distance is A. This distance is B, and always C is the largest. So regardless of which one you have, a squared plus b squared equals c squared. Because according to the Pythagorean theorem, the one that is the largest becomes the hypotenuse in essence. All right. So both of these have center at 0, 0. A is square root of 16, b is square root of 25, a is 4b. So both of them have that situation. And therefore, both of them have the asymptote plus minus b over a, 5 over 4x. So that's the center. That's the asymptote. And the asymptotes are identical. So far, everything is the same for both. What is the difference here? I want you to notice x squared has a coefficient of 1 over 16, which is positive, whereas here y squared has a coefficient of 1 over 25, which is positive. When x squared has a positive coefficient, it opens sideways, everybody. And it's easy to see. If you set y equal to 0, x squared over 16 is 1, x squared equals 16, x is plus minus 4, which is the value of a. Okay? If you set y equal to 0, x squared becomes 16. Okay, so the vertices are at a 0 and negative a 0, 4, 0, negative 4, 0. So I hope you see that. And that's a graph. It just follows that. If in this case, and by the way, if you set x equal to 0, y doesn't give you any solution, becomes y squared is minus 25, no solutions, okay? This one uses exactly the same thing, but it opens up and down. In this case, the vertices are b 0, 5, and 0, minus 5, and it opens up and down. So this one opens up and down, this one opens sideways. The other thing that I want to add is what you're looking at, this rectangle, which is called fundamental rectangle, everybody. They can also help you find the asymptotes. How? These are the 4 points that can give you the rectangles. This one is a comma b in general. This one is A minus B. This one is minus AB. This one is minus A minus B. The diagonals are the two lines. So if you draw a fundamental rectangle, or if the fundamental rectangle is given to you, you should be able to draw this. So in this case, becomes something like this. Let me see if I can do that. Something like this. Okay. So that should be fairly easy to see. Okay. You see the diagonals are. So just to give you an idea. All right. Identify the coordinates of the center, the vertices, foci, and the equation of asymptote, graph the hyperbola. So as you look at this one, you compare it to this, and the center becomes 1, comma 2. A becomes square root of 9 or 3. B becomes square root of 16 or 4. So that's just in a matter of comparison to this one. Oh, by the one of these two. And what matters is because 16 is larger, that means the denominator of y squared in essence is y minus 2 quantity squared. Okay. It doesn't make any difference. The formula for the asymptotes, I'll explain that in a moment. There's a slight different than what we have seen. And a squared plus b squared equals c squared doesn't change. All right. So the way the asymptotes work, remember, it was y equals plus minus b over a times x. So instead of y, we're going to put y minus k. And instead of x, we're going to put x minus h. So y minus k is y minus 2. X minus h is x minus 1. We can move the negative to make it positive 2. And if you go with the positive 4/3 x, let's see what color I want to use. So if we go with 4/3 x, we get minus 4/3 because of negative 1 and then plus 2. And that gives us 2/3. Of course, clearly 0 2/3 is the y-intercept, and if you set y equal to 0, x must be negative 1/2. So those are the pairs. And you can see the graph. By the way, this is the center 1, comma 2, okay? And by the way, the asymptote, because you have 0 2/3, if you don't want to come up with that, it has to go through the center. So you can come up with it. Now, if we go with the negative 4/3, I'm going to write at top of it y equals minus, if I go with the negative, so I get minus 4/3. Let me erase my work. So with the negative, y equals negative 4/3 x times this one becomes positive 4/3 because negative times negative plus 2, and we get this one. Y equals minus 4/3 x plus 10/3. And so what are the asymptotes? What are the intercepts? Obviously, 10/3, that means 0, 10/3. And then you can connect it to that one. Remember that? Or if you go with the second one, you set y equal to 0, you get 10/4 or 5 halves. And if you graph it, it looks like that. And remember, because the coefficient of x is positive, it opens sideways. And now, basically from the center, we're going to go 8 units, 3 units to the right. The center was located at 1, 2. So we go 3 to the right becomes 4, 2. And then 3 to the left, 1 minus 3, negative 2, 2. Okay, so A equals 3 units to the right and left of the center will give us those two pairs. Which we call them the vertices. That's the graph. All right, so go back to this. Okay, so we have the center, yes. Vertices, yes. Equation of the asymptotes, yes. Graph, okay. What is missing? Foci. So the foci are going to be here, okay. So from the center, we go C units to the right, C units to the left. To find that, we follow a squared plus b squared equals c squared. So a squared is 9, b squared is 16. You can say 9 and 16 is 25. And c becomes 5. So if c is 5, and the center is at 1, comma 2, this is the center. We don't want to mix it up with this lowercase c, this capital C representing the center. Okay. So we're going to go C units. That means 5 units to the right and left. Okay. And so to the right, 1 plus 5 is 6. To the left, 1 minus 5 is negative 4. Those are the foci. So pretty straightforward, everybody. Use the graph of the hyperbola to determine its equation in standard form. All right. So clearly we have the asymptotes, we have the center, we have this distance, that distance. So let's write everything we want. The center is located at negative 1, 0. All we have to do, find A and B. And since it opens up and down, the vertices are these 2 points. So that's the center, okay? And the vertices are at negative 1, 3 and negative 1, negative 3, right? These 2 points. And so we want this distance. So located B units up and down from the center. And if you look at this distance, have the same x coordinates, the y coordinates, the difference is 3, or you can go here. Either way shows that this distance B must be 3. So we have B equals 3. We also have the foci location, this one is -1 minus 3 square root of 2. This is -1 3 square root of 2. So the distance here gives us the C. So foci, C units up and down from the center. So this point. And so we are looking at this distance. Obviously, is just 3 square root of 2. So C is 3 square root of 2. So we have a B, we have C, A squared plus B squared equals C squared. We plug in A squared plus 3 squared equals 3 squared of 2 quantity squared. Now, as you know, this is 9, and this one, by the way you do it, everybody, you square this one, you get 9, and you get this one is 2. 2 times 9 is 8. So that means 9 and A becomes 3. Now, which formula are we using? This one or this one? Because it opens up and down, we use this one. That means the coefficient of y must be positive. And y minus k, that means y minus 0 or simply y squared. X minus h, that means x plus 1 quantity squared. B and A are identical. A is 3, so it's B, so both of them are 9. Because we are scoring it. And what about the asymptote? Y minus k. So just put this one, y minus k, simply y. Plus minus b over a, 3 over 3, x minus h, that means x plus 1. Obviously, this is 1. And we get plus minus x plus 1 as the final answer.